All right, so we're all getting pretty excited about AI agents with long-term memory, right? But there's this huge elephant in the room kind of problem we're not really talking about enough. How do we know that memory is actually reliable? Well, that's what we're diving into today. We're looking at a brand new diagnostic tool called HaluMem. Think of it like a super detailed stress test for an AI's memory, designed to find the exact point where a memory goes off the rails and becomes a hallucination. Okay, take a look at this. This example from the paper just nails the problem. You ask the AI, what's Barbara's job title now? The right answer, the golden answer, is senior researcher. But the AI says lead research scientist. Now, you might think, okay, close enough, what's the big deal? But this is exactly what the researchers call a memory hallucination. It seems small, but imagine these little errors piling up over weeks, months. The AI's entire understanding of you gets corrupted and poof, there goes your trust. The real kicker, though, is trying to figure out why it got it wrong. So the researchers have a specific name for this, and it's memory hallucination. And it's not just, getting a simple detail wrong. It's way deeper. It's when this system completely fabricates something, or misremembers, or, and this is a big one, it fails to update old info, just like with that job title. So as we're all dreaming up these long-term AI assistants, you can see how this becomes a massive problem. These tiny errors start to stack up, and before you know it, the AI's memory is like a funhouse mirror reflection of reality. And yeah, this leads us right to the core problem, the big diagnostic headache. For the longest time, if an AI agent spit out the wrong answer, we were basically stuck. It was a total black box. Was it a memory failure? Did it just forget the fact? Or did it actually remember the right information, but then totally mess up the reasoning part? If you don't know where the breakdown is happening, how in the world are you supposed to fix it? It's been a huge roadblock. This is where this paper really shines. It's the core innovation. See, up until now, pretty much all evaluations were end-to-end. You'd ask a question, you'd get an answer, and you'd grade it. That's it. A total black box. It's like judging a car just by how fast it goes, without ever looking under the hood. What HaluMem does is introduce what they call an operation-level approach, a glass box. Instead of just looking at the final answer, we can now pop the hood and inspect every single part of the memory process. How it pulls in new info, how it updates old info, and how it finds that info to answer a question. We can finally pinpoint exactly where things are going wrong. So this new glass box toolkit is HaluMem, the Hallucination in Memory Benchmark. And its whole reason for being is pretty straightforward but really powerful. It's here to make us stop treating AI memory like this one big, mysterious thing. Instead, it lets us systematically test each of the individual gears that make the whole system turn. So how does it actually work? Well, HaluMem breaks it down into 3 critical jobs. First up is memory extraction. Basically, did the AI even notice the new piece of information and write it down? Second, memory updating. When something changes, like that job title, can it find the old memory and correctly update it? And finally, the big one, memory question answering. Can it actually use everything it has stored to give you a correct answer without making stuff up? Okay, but here's the thing. To test each of those stages separately, you need some seriously specialized data. You can't just grab any old data set off the shelf. Nope. You have to build one from the ground up, a really rich, multi-turn conversational data set. And it has to be meticulously crafted with specific memory points, updates, and even distractor information, all so you can precisely measure how the AI is performing on each task. And this pipeline just shows you how wild that process is. I mean, look at this. To make a test that's actually reliable, they basically had to play God. They generated entire synthetic lives, they built detailed user personas, gave them life goals, mapped out their whole life story. It's incredible. And all this work allowed them to create thousands of controlled conversations where they always know the ground truth. They know exactly what the user's memory should be at any given moment, which is the only way you can accurately grade the AI. All right, so the team built this incredible new microscope. The obvious next step? Put today's leading AI memory systems under it. And let's just say the results, they revealed some pretty critical weaknesses. So let's look at the high-level numbers here. The really important thing to watch is the difference between the medium and long datasets. That long one is full of distractor info, just like a real messy conversation. And wow, for a system like Mem0, you can see its performance just falls off a cliff in that long context. Supermemory, on the other hand, holds up surprisingly well, which is impressive. But the overall takeaway is pretty clear. Most memory systems today just aren't built to handle long, complex interactions.
And just to really hammer this point home, look at this number, a 92.5% drop. That's how much Memzo's memory recall ability plummeted when moving to the long context dataset. It just goes to show you how brittle these systems can be. The second the conversation gets a little long, a little noisy, they basically just stop making memories, which for a long-term AI assistant is a complete deal breaker.
What's also cool about this benchmark is that we can slice the data by the type of memory. And what we see is that the systems are okay-ish at remembering stable persona stuff, like your job or where you're from. But when it comes to dynamic event memories, like where you went on vacation last month, or relationship memories, they really, really struggle. It seems like tracking the actual unfolding story of a user's life is still a massive challenge. And the performance difference doesn't stop there. It also changes a ton based on the kind of question you ask. Simple fact recall? Yeah, they can handle that fairly well. But look at what happens with multi-hop inference. This is where the AI has to connect the dots between different memories. Like if it knows you went to Paris and it knows you love art, it should be able to infer you probably visited the Louvre. But on these kinds of questions, performance absolutely tanks, down to around 20%. This shows a huge gap between just storing facts and actually reasoning with them. So what's the big takeaway from all this data? It's this. HaluMem proves that the bad answers we're seeing at the end aren't just random mistakes. They are a direct symptom of problems happening way earlier in the process. It's a cascade failure. The system messes up extracting the memory or updating it. Those are the upstream errors, and that's what directly causes the downstream failure when it's time to actually answer a question. Okay, so we've got a clear diagnosis of the problem. What's the prognosis then? Where do we go from here? What does all this mean for the future of building AI memory that we can actually trust? Well, HaluMem pretty clearly lays out 4 major bottlenecks that are holding everything back. First, low coverage. They just miss a lot of important stuff. Second, poor update logic. They're bad at letting go of old, wrong information. Third, they're fragile at scale. As we saw, they just crumble during long conversations. And finally, there's a big efficiency problem. The whole process of writing information to memory is a huge computational bottleneck, and it slows the whole system down. And because of all this, the paper's conclusion is crystal clear. We're not going to solve this just by making our models bigger. That's not the answer. The real path forward is to design fundamentally better memory mechanisms. We need systems that are more interpretable, more constrained, systems where we can actually understand and control exactly how information gets written, updated, and read. And so that really leaves us with the big ultimate question for the entire field, doesn't it? We've kind of solved the basic problem of just storing data. The next great frontier is building an AI memory that genuinely understands the nuance, the dynamics of a relationship, the context of a conversation, the way truth itself can change over time. Now, HaluMem doesn't give us the final answer, but what it does do for the very first time is give us the right tools to finally start asking the right questions.